Hey guys, Marvelous Maths here, and today we'll be looking at the Mind-Blowing Universe, Episode 2, What is a Black Hole? Okay, what are black holes? Okay, so according to Google, a black hole is a region of space having a gravitational field so intense that no matter or radiation can escape. And there you go, folks. That's the end of this episode. Bye. Okay, you can go now. Why are you not going? I've finished this video now. What do you mean you didn't understand? It's so simple. It's a region of space having a gravitational field so intense that no matter or radiation can escape. What's so hard? Okay, fine. Let me explain to you. You all know about gravity, right? Phew, at least I don't have to explain it. You know, the reason that we don't fly off Earth is because of gravity pulling us to the center of the Earth. Not too hard, otherwise it would crush us, but not too light, otherwise we would be able to jump really high, like on the moon. Anyway, the gravity of the black hole will suck anything in, and and if you happen to get sucked by a black hole, then you'll probably turn to spaghetti. But more on that later. Well, you might be wondering, how are black holes formed? Well, if a dying star, an extremely dense dying star, implodes on itself, then a black hole occurs. Okay, let me explain again. Imagine everyone in the world had a car, and all those cars were put in a box, small box. And you managed to put all those cars without the box breaking. Just suppose everyone in the world has a car. And all those cars are put in the box. They can't break. The box would be really small and compact, but it would be extremely heavy, like really heavy. So it can't handle that much, so much crammed into such a little space. In time, it implodes on itself and creates a black hole. So, technically speaking, you could create a black hole on Earth, but nobody's ever done it before, because nobody wants to destroy the Earth. Okay, back to spaghetti. When I say if you go near a black hole and you turn to spaghetti, I'm not saying that you're actually going to turn to pasta. I'm saying that the gravity will stretch you as thin as spaghetti, and this is actually known as spaghettification. And when I say nothing can escape, I mean nothing can escape. Not even light can escape. And that's saying something, because let me just remind you how fast light is. In 1 second, light can travel around the world 7 times. Just 1 second. So, you want to know how to escape one, right? You don't? I'm gonna tell you anyway. Particles that can. And they're called Hawking radiation. Named after the famous theoretical physicist Stephen Hawking. On an unrelated note, is it weird that he died on Albert Einstein's birthday, which was also on Pi Day? And if you don't know, Pi Day is actually the 14th of March. If you don't know what I'm talking about, then you can watch my Pi video. See, there's one thing I haven't told you about black holes yet. They have something called an event horizon. It's basically a gate for the black hole. where if you go past the event horizon, only then you'll get sucked in by the black hole. But if you're outside the event horizon, then it's okay. And you might be thinking to yourself, why is this important? Well, it'll come in handy later. Okay, so we have these two particles. This is a virtual particle and this is a virtual antiparticle. Very memorable names, just putting virtual in front of particle and antiparticle. Okay, so you may have learned that space is a vacuum, which means it's literally empty. No air, no dust, nothing. It's empty. Except for one thing. These virtual particles and antiparticles keep on popping up in space and get attracted to each other. Because positive and negatives attract, and they destroy each other. So if the virtual antiparticle, not the regular particle, if the virtual antiparticle, if one of the particles appears to be beyond the event horizon and it's getting sucked in, either two things can happen. One, the other particle outside the event horizon will follow it. And the second option is if the other particle leaves and finds a new partner to annihilate. And that's known as Hawking radiation. Now you may have heard that there is a black hole in the center of our galaxy, the Milky Way. And that is 100% true, except it doesn't suck anything in anymore. And if you're worried about a black hole sucking the Earth inside, you don't really have to worry. In fact, if you replace the sun with a black hole with the same mass and the light around it was hot enough, then nothing would happen. Everything would still be there. All the planets would be in orbit and everything would be fine. And let me end this video with a quote from the man Stephen Hawking himself.
So, if you feel you are in a black hole, don't give up. There's a way out.